Welcome from my side. My name is Markus Hummel. I work for eThink Energy Research, which is a small research and consulting organization located in Vienna. I work since more than 10 years in the field of heating and cooling, analysis, modeling, and planning. This includes buildings as well as district heating. And I have the pleasure today to bring you through these next 1.5 hours session, a webinar in course of the X-tendo project. X-tendo is a Horizon 2020 project that has started 2.5 years ago, and it deals, if you could please go to the next slide, Roberta, and it deals with several ideas of how EPCs, so energy performance certificates of buildings, can be further developed. We have 10 dimensions that we have worked on in the last 2.5 years, half of it, so 5 of it, dealing with new indicators that might be interesting to be included into EPCs, and another 5 features, we call them, that deal with how could data related to EPCs be better worked with, be better elaborated, be better included in other platforms. All of that, we have also, all of these developments, we had a look that they are also compliant with several criteria, cross-cutting criteria, we called them, like economic feasibility, compliance with international standards, quality and reliability, as well as user-friendliness. So, and now this is the first out of 5 webinars now where we want to share our work that we have done in the last 2.5 years with you. We're going to have 2 webinars related to features dealing with indicators. One is the comfort indicator that we are going to discuss today. Another one will be the real energy consumption indicator that will be the topic next week. Then we're going to talk about building logbooks. We're going to talk about EPC databases and how these can be improved. And we are also going to talk about those cross-cutting criteria and how these were used and are useful or not in the validation or evaluation of further developments of EPC. So as said, today we're going to focus on the developments and the analysis and the testing that we have done in course of the comfort feature. So, yeah, okay. So maybe maybe you go to the agenda. So it should be yes. Yes. So actually, the EPCs are a means of making transparent the energy demand or the energy performance of buildings. And of course, we all know that the energy performance has to increase. We have to increase energy efficiency and by that decrease energy demand. We also know that this can have multiple side effects, multiple benefits, like for example, also the increase of the comfort in a building or the healthiness in a building. So now, why not turning that around and including an indication for the comfort into the EPCs? That was basically the idea, why to work on a comfort indicator that could be included into the EPC schemes. And we will see today what we have done in course of the project. So what the colleagues from BPIE mainly have done in order to come up with a method to measure that. Sheikh Zouib will present this to us. After that, we will also hear from colleagues from the Center of Renewable Energy Sources from Greece about testing these indicator sets in their countries. And before that, we will hear an introduction of Pau Garcia Audi from DG ENER about recasting the EPBD and the specifications for the update of EPCs that might be upcoming. After those 3 inputs, we are going to have a panel discussion with all of the presentation of the presenters. Next slide, please. Yeah, be aware that this webinar is going to be recorded. So in that sense, yeah, do not turn on the video. And also you can take into account to delete your name or change your name in the list of participants. Also, please, if you have any questions, we are very happy about it. Please put your questions into the chat, and we are going to take them wherever they fit. Directly after the presentation, if we have after the presentations, if we have a little bit of time, but mostly then in the panel discussions. Yes, and in that sense, yeah, let's start with the first input, Pau. The floor is yours. Now it's 14:26. We set to have 15 minutes, so which would mean 14:41, and I will remind you 5 minutes before the end.
Thank you. I'm also putting a timer just in case. Thank you very much, Marcus, and thank you very much to the X-tendo project also for inviting us to be here today. I don't have a lot of time, but a lot of ground to cover, so I'll just jump straight into it. So Roberta, if you could just jump to the next slide, please. So first of all, as you may know, the Commission's proposal for the recast of the EPBD was adopted on the 14th of December. It is now available in all EU languages, so you can check it in your language if you want to. Very, very important to highlight, this is a proposal. There's still a long process to go through. We still have a long process to go through. We still have to discuss and negotiate the whole package with the Council and Parliament, and bearing in mind also that this is part of the larger Fit for 55 package. So there is a lot of elements that still need to be discussions, and also integration and interactions with other policy initiatives. Nevertheless, we have the recast of the EPBD. It mainly has two objectives. The first one is to make sure that it's that the building sector is ready to contribute by reducing the greenhouse gas emissions and final energy consumption to ensure that we can reach the objectives by 2030. And after that, there is also the objective to provide this long-term vision. So we know that the building sector is very slow, not just to renovate, but also to build new buildings. So it takes a long time to go through the whole of the building stock. So we need to make sure that we provide a long-term vision for these. So just to put it as an example, the average time that it takes for a building to be renovated is between 20 to 30 years. This means that at least anything that we build from 2030 onwards needs to already be ready by anything that we build by 2030, more or less, will need to be ready to achieve the objectives of decarbonization by 2050, because the likelihood of a new building being renovated before 2050 is very low. Next slide, please. So this is just to illustrate the importance of the building sector. We've always highlighted that it approximately represents 40% of energy consumption in the EU. Just to put it into perspective, the contribution of the EPBD to the Fit for 55 package is about half. So you can see it in the graphic. If we take out the EPBD, we will not be able to reach the objectives. Overall, the revision of the EPBD should contribute to the climate target plan, which requires a reduction in greenhouse gases emissions of 60%, a reduction in final energy consumption of 14%, particularly in the sector of energy for heating and cooling. This reduction should reach up to 18%. Next slide, please. There are four main focus areas in the EPBD. The first one is renovation. There are a number of initiatives there, but basically the EPBD aims to ensure and trigger, it aims to trigger as many renovations as possible, and then it aims to ensure that those renovations are of high quality and standards. So for these reasons, we have a number of measures, particularly the minimum energy performance standards, an upgrade of the energy performance certificates, but also the introduction of the building renovation passports and the national building renovation plans. In the area of decarbonization, in the focus area of decarbonization, we also have a number of initiatives that aim to make sure that the buildings, they are not just much more energy efficient, but also they are as decarbonized as possible. And for these, we introduced the definition of zero emission building, which will be a new standard for all new buildings from 2030 onwards. We also start to evaluate how we need to consider the whole life cycle carbon emissions. There are still no specific requirements on this, but there is a requirement. There are no requirements to achieve a certain level of whole life cycle carbon, but there are requirements to start reporting on these. And finally, there is a number of measures to allow the phase out of incentives for fossil fuels and a new legal basis for outright national bans. Then we also have the fact that there is a lot of new technologies coming into the market. So we have a focus area on modernization and system integration. This particularly makes reference to the infrastructure for sustainable mobility, support to smart technologies through the smart readiness indicator, and then also making sure that the buildings are fit for their purpose, which is to make sure that they are safe and comfortable space. And last but not least, we have finance, which is an enabling area. At the end of the day, all of these measures will need to be financed one way or another. So there are a number of measures that we're putting in place to facilitate and make sure that this finance is available. And I should highlight it's not just purely finance. There's also a good level of making sure that there is a technical assistance and administrative support when necessary. Next slide, please. So on the main provisions for new buildings, as I mentioned, we have a nearly zero energy to zero emission building provision. So as you know, we already have the nearly zero energy building requirement, which is in place since the end of 2020. We are now updating it to a zero emission building. So this is a type of building that will be ready for 2050. The main change is that a zero emission building will need to have a very high energy performance, and the remaining energy consumption will have to be 100% supplied from renewables on site. It can also be supplied through district heating and cooling or energy communities, or also in some cases through the grid. So there is a stronger incentive there for on-site renewables and efficient district and heating and energy communities. We really want to make sure that this link with on-site and the vicinity of the building is as strong as possible. These buildings have to become the level to be attained by deep renovation also as of 2030. So the deep renovation is now redefined, and it's to bring a building up to this zero emission building standard. We also, as I mentioned, introduced the requirement to calculate the life cycle global warming potential of new buildings. This has to follow the levels framework, and it's purely as an information. There is no requirement to reach a certain level, a maximum or minimum level of emissions. It's just a procedure to report because we see that the first stage in making sure that we can address the issue of full life cycle carbon is, first of all, we need to be able to measure. And then there is also strengthened requirements for recharging of electric vehicles and mandatory bicycle parking in new buildings. This is to address the whole issue of immobility. Next slide, please. So on existing buildings, perhaps the star of the recast of the EPBD is the introduction of minimum energy performance standards. This is a specific measure to make sure that we trigger the renovations of the worst performing building stock, which is where the most potential for energy savings is. There are different steps for different kinds of buildings. So for publics and other non-residential buildings, they need to reach at least Class F by 2027 and at least Class E by 2030. In the case of residential buildings, they need to reach at least Class F by 2030 and Class E by 2033. We recognize there the fact that for residential buildings, it's more complicated and we need more time to adapt. Member states need to set up timelines for further improvement of the building stock in their building renovation plans beyond these 2030 and 2023 timelines. These requirements don't come alone. there needs to be a supporting framework specifically for or particularly for vulnerable households, and make sure that we monitor the social impact of these measures. The other main provision on existing buildings is the introduction of national building renovation plans. They substitute the long-term renovation strategies. They are better integrated with the whole NECP process, and they provide a common template with common elements for all member states. Other measures include the definition of a deep renovation, which is a renovation that brings a building up to zero energy building level. There are also strengthened requirements similar to new buildings for recharging of electric vehicles, and stronger provisions on the removal of obstacles to and barriers to renovation. Then there is a clear ban for the subsidy of fossil fuel boilers as of 2027. We also introduce we make it easier for member states if they want to introduce bans on the use of fossil fuel boilers in their territories. Next slide, please.
5 minutes left.
Thank you, Marcus.
Welcome.
On the main provisions on information tools, this is I believe the main topic of discussions for today. The main one is the energy performance certificates. There are a number of measures there. On the harmonization and coherence at EU level, we've introduced a rescaling and relabeling of the system. So from 2025 onwards, all energies performance certificates will have to be based on a harmonized scale of energy classes. This still allows for flexibility to member states. So because the building stock is in each member state is very different, and there are also differences in the calculation methodology, and we recognize the need for this flexibility, but at least we wanted to make sure that we introduce common elements in the way these classes are defined. So A class is now defined as a zero energy building, which has which has also a clear framework at EU level, and the G rating building is representative of the 15% worst buildings in that particular member state. The EPC is also updated with a common template, which has energy and greenhouse gases emissions indicators. There are other indicators that remain voluntary. Again, we need to make sure that there are certain coherent elements across all the EPC schemes, while we also allow for flexibility. In order to reflect the fact that we are in a changing building stock, the validity of energy performance certificates, particularly for the lower classes, is reduced to 5 years. Other measures that are not included in this slide, but I think are also particularly relevant, is the need to upgrade the quality and the quality scheme of EPCs. Particularly now that we're introducing minimum energy performance standards, the value of an EPC is much greater than before, because it has specific implications and financial implications in some aspects. So we need to make sure that the EPC is valid and of the necessary quality. So we've introduced a number of measures in this area. Other provisions on informations, the smart ventilation indicator is required now for large non-residential buildings as of 2026. These are buildings over 290 kilowatts. We also introduce the building renovation passport. And all these three elements, so the EPC, the smart ventilation indicator, and the building renovation passport, will now fall under a common database for information on buildings' energy performance data. This database will be publicly accessible, of course, complying with GDPR rules. But on top of it, also member states have to report on certain elements of these databases. There are also updates to the methodology for calculating the energy performance of buildings and EPCs, and particularly to make sure that we clarify how the use of metered energy and also, sorry, how the use of metered energy can be done on the calculation of the energy performance. And we are going to update the cost optimal methodology to take into account other elements such as carbon and even externalities such as thermal comfort in buildings. Next slide, please. And if I'm not mistaken, yes, that was the last one. So I'm pretty much on time. If there are any questions, I will remain available later on. But of course, we also have the panel. Thank you very much.
Thank you, Paul. Perfect. Thank you for this great introduction into the topic. Actually, I don't see any question in the chat so far. So again, to all of you, if you have any questions, please post them in the chat and we will definitely try to pick them up in the panel discussion. As there is no question right now, let's go on into the next presentation and use the time afterwards for discussion. So next is Jake Sueb. Please, the floor is yours. It's 14:40 and we said you have 20 minutes, so we are at 1500. I will remind you 5 minutes earlier. Again.
Thanks, Marcus. And welcome everyone to this presentation regarding the comfort feature that we developed in the X-tendo project. I would like to also thank Pao for sharing the strides that EPBD has made, and they are trying to cover the ground that has always been the intention of these H2020 projects, to bring new research into picture. In the X-tendo project, we did a stakeholder investigation in the beginning to identify what information in the EPCs would interest our end users most. And comfort feature have actually been on one of the top information that people have been seeking into EPCs, and it would also help them to take some very key decisions. Can you change the slide, please? As we know why comfortable feature is important, 60 to 90% of the time we spend in the indoor environments. And that is why people are actually looking for this information to understand how can the comfort information about the building in which they're spending time can help them in taking right steps for their health and well-being. Also, in terms of space satisfaction, what really they need to do to increase their space satisfaction, whether it's a school, it's an office building, or it's a residential building. It also have a very huge impact on the economic and marketing advantage, as the real estate would have a very different perspective towards looking into that. And then we can also say that there are different psychological and productivity impacts that we can expect if we know and we do comfort evaluation of the existing buildings. Next slide, please. Now, where we got the inspiration to develop this feature, you might be wondering that already there are so many rating systems out there which are evaluating comforted buildings, but our intention was not to develop something what already exists out there. Our intention was to develop a cost-effective, easy to use, and a quick assessment, which does not take too much time or cost and could be well integrated in the EPC system within the defined limits of the EPCs. So we took our inspiration from our existing rating system, as you know on the screen, BREEAM, LEED, and also from Levels, which was recently developed by the European Commission. One of the projects like ELDRIN from H2020 projects, which have looked into this aspect, and also several other rating systems. So we took the inspiration in order to understand what criteria do we really need to take into account, because comfort has always been a very complex topic to look into and to evaluate and actually provide information which is very useful to the end user, yet in a simple form. So we have looked into these existing rating systems very deeply. We considered all our options and then worked on developing a comfort feature which could fit well into the EPCs. Next slide, please. So what were the main objectives in X-tendo? What we were aiming at? We were aiming at to enrich the EPCs with key indicators of building performance other than energy efficiency. The idea is that we have several parameters that show the energy efficiency of a building on EPC, but the indicators that actually predict or tells you what is the comfort level inside the buildings are missing at the moment, and hardly are there in any of the EPCs that are being produced in different member states. The idea is also to increase awareness and willingness for improvement of comfort. People do live in cold buildings. People also keep their buildings overheated because of their personal preferences. But there is less awareness what should be done and how they can really achieve a better comfort in a cost-effective way, balancing the energy efficiency together. So this feature is also focusing on that objective. We also wanted to promote health and well-being in built environment and understanding among the common end user who really don't look into these aspects very as an important aspect, and it impacts their day-to-day lives, their health, and even the cost on their healthcare. We wanted to extend the multiple benefits to the customer for new and existing building. As we understand that energy efficiency renovation has different multiple benefits in terms of cost or economic benefits, then there are health benefits. We wanted to emphasize that these benefits can be achieved, and to provide a clear information to the user would help us achieve the extension of multiple benefits to the customer and motivate them to actually renovate their building from a point of view of having a better comfort and healthy living inside their buildings. Next slide, please. We faced a lot of challenging while developing comfort feature, as this has not been attempted very often, and researchers have been working on different areas. We identified that there are so many building typologies, and each building typology has a different use. So we tried to understand different building typologies and come up with a solution that could fit the need that are out there, and also create a comfort feature which could fit well into these building typologies. We also look different scales. As you know, that energy rating is defined into A to G scale, and there can be different scale in which it can be presented. We looked into different measurements type, as comfort is not just one measurement, it is a amalgamation of a lot of indicators to derive to a value where you can understand what is the comfort level inside the building, be it be thermal comfort, acoustical comfort, visual comfort, or indoor air quality. Scoring and rating has been one of the challenges in trying to define what could be the score or rating that the end user can simply understand, and it is easier for them to transpose that into their actions. We also wanted to look into different baseline performances, which means what level of performance should be there in a building. So we considered different standards while developing this feature. We also looked into having end user surveys or having interaction or perception of the end user in the building. We have taken that into account. We worked on different aspects of industry readiness, how the industry will react to what we are producing and how it will be useful to them. We tried to develop the feature keeping in mind whether this rating will be for the whole building or it is going to be for a zone, and how cost effective it is going to be. So as you see, there are only 9 main aspects written in front of you, but there are many more which we have looked into developing this feature in a holistic way and tried to formulate them in a cost effective and affordable manner. Next slide, please. So how we develop it? What we did, we developed it as a flexible assessment, which could be used in different building typologies, such as domestic and non-domestic buildings. We based it on the 4 main indicators of comfort, or I would say indoor environmental quality. And these are thermal comfort, indoor air quality, visual comfort, and acoustic comfort. We have taken into account different scores for all the indicators, and there is a combined rating for all the indicators as well. And this is, as I said, a very affordable and time efficient assessment, and I will explain that in the coming slides. Next slide, please. We have taken into account 3 assessment approaches in our comfort feature. As you know, and I also said that we have taken measurements as one of the important aspects of our assessment, but also use different approaches such as checklists and surveys for several data capturing exercises that the assessor will do on site and gather this information. Next slide, please. So what is the solution that we have done and what we have designed for this feature that we have been talking about? There are 2 solutions that we have developed. One is known as a comfort operational rating procedure, which is actually useful for new buildings and renovated buildings that are occupied already. So which means this is a more comprehensive assessment than the buildings which are not occupied. We developed an assessment for buildings which are very new, which are recently constructed and they have to be rated, and also buildings which are renovated and they still require a certification. So we developed a comfort asset tracing procedure for those kind of buildings. The main difference between the 2 is that CORP has measurements as well as a comprehensive checklist and surveys to calculate the rating, whereas in CARP, we don't have measurements, we have only checklists, and there are no surveys because there are no occupants involved. So it is basically an assessment of a building which is recently constructed. So we developed these 2 solutions to fit the needs of the industry. Next slide, please. What building types are being tested? What we have done after developing the feature, we wanted to test in different buildings, but the development of the feature was limited by certain factors. So in residential buildings, our assessment of comfort is primarily based for the space which is most of the time occupied or for larger hours throughout the day, that is the living room. For the office buildings, we have taken into account a typical office less than 15 square meters occupied by 1 to 2%. And in a school, we have taken representative space of a classroom which is less than 50 square meters. So at the moment, the limitation of the feature is that we have restricted the evaluation of comfort feature to certain zones, as we cannot really evaluate the whole building very cost effectively. But these representative zones are the zones which are occupied most of the time throughout the year in different seasons. That is the primary aim of taking this into account. Next slide, please. How do we score COD and CARB? Both assessments have a similar way of rating the comfort inside the building. As you can see, we have a combined rating, which is a comfort rating, and it is composed of indicators, which are 4 indicators: thermal comfort, IAQ, visual comfort, and acoustic comfort. But to assess each indicator, we have a criteria. Now, this criteria has certain parameters which are assessed using the 3 approaches that I already told you, that is the checklist, survey, or measurements. So the scoring actually follows this pattern and finally combines to a comfort rating. But in the next slide, I'll explain you how different weights are assigned to these parameters and criteria, and finally achieve at a rating. Next slide, please. As you can see, this is an example for evaluation of thermal comfort. In the first pie chart, you see that there are 4 aspects that we are assessing in comfort rating, that is thermal comfort, IAQ, visual comfort, acoustic comfort. By default, we have kept the weightage of all the indicators as equal. But to understand how weighing works, we move on to the second level, which is the criteria level. As you see, thermal comfort has 4 criteria in it. That is thermal sensation, summer comfort, winter comfort, operational control. Now further, to assess thermal sensation, we have two parameters, which is local thermal discomfort and occupant perception and satisfaction. Each of these parameters and criteria have been given a weight, and finally, they are calculated to calculate the rating for thermal comfort, which is combined with rest of them. So there are 3 levels of weighing that we have taken into account in the calculation tool. Next slide, please. Thermal comfort indicator is composed of 4 criteria: winter comfort, summer comfort, thermal sensation, operational control, and we have several parameters under them to actually calculate the rating for thermal comfort inside the building. Next slide, please. Similarly, we have indoor air quality indicator, where we are assessing contaminants inside the building, the ventilation, indoor air quality satisfaction, that is capturing occupant perception, and also operational control. Next slide, please. In visual comfort indicator, we have 3 criteria, which is about illuminance levels. So we are assessing natural light and artificial light and illuminance levels. We are also assessing occupant perception and satisfaction through surveys. And we are also calculating the operational control indicators, criteria, using the parameter of lighting and glare control. Next slide, please. We also developed acoustic comfort indicator, where we have 3 criteria to calculate the acoustic level inside the building, which captures indoor noise and outdoor noise. And then again, we have occupant perception and satisfaction, followed by operational control, which tells us what flexibility does the user have to control the noise inside the building. Next slide, please. So as you see, I have given a very brief insight into the methodology, or what are the main indicators or parameters we are looking at, which is quite comprehensive and quite less time I have to share that with you, but it was an overview. Here is a snapshot of the rating tool that we have developed, and this is for the CORD. Similarly, we have a rating tool for CARB, and this tool has been developed for residential, office, and school building. And this is being tested by our implementing partners of the project in Greece, in Portugal, also in few other member states. So the main aim is to see how this tool works in real life and how we can calculate and evaluate CORB versus CARB and what results are. Next slide, please.
5 minutes, Sweep.
Thank you. So as you see, how we are going to display the rating for the assessor, or that finally can be transferred to the EPC certificate. We developed a scale which is very simple and easy to understand. We have a scoring from 0 to 10. As you can see, there's a dial which actually shows what is the level of overall comfort inside the building, if it is acceptable. And at the moment, if you see 5.4 is a value that is there, which shows a score which makes the overall comfort level of the building acceptable. Now, this is a combined score for thermal comfort, acoustic comfort, IAQ, and visual comfort. I'll show you what is individually given for each indicator in the next slide. Next slide, please. The individual rating and score is also calculated for 4 indicators, as we understand that not all the indicators are relevant for either the end user or different types of building. For example, in office building, maybe acoustic comfort indicator is more important than visual comfort indicator, or for a school building, acoustic comfort indicator may be more important than indoor air quality. It really depends. So we have tried to build a flexibility in the tool that could support the end user in different ways, and also does not complex the whole calculation or evaluation of the feature, and could be integrated easily in the EPCs. Next slide, please. Like I said, the feature has been developed and now being tested in Romania, Greece, and Portugal. We have several buildings that are being tested, and our partners from Greece will share their outcomes in their presentation, followed by me. So I think this is my last slide, and I thank you and I welcome any questions. I think in the meantime, Marcus, we have some time to address some questions.
Yes, thank you, Suhaib. Great, thanks for the introduction. Actually, yes, we have a question, a concrete question that we might pick up at the moment. It's from Roger Hitchin about how to deal with open offices. And here, especially, if I understand correctly, speech privacy, related speech privacy and intelligibility. Yeah, do you have any thoughts about that, Suhaib?
Yes, thank you for the question. I think it is very relevant. While doing the exercise of working on developing the comfort feature, we came across that there are several ways in which open plan offices or larger offices, more than 2 people or 10 people, their comfort level could be evaluated. But we found that it is a complex problem and does not have one solution, as there are many occupants that are regulating or trying to have a comfort level. We understand that each occupant has their unique requirement to have comfort in that space. And often one setting for the HVAC system or for the heating or for the shading or for lighting is not equally required or satisfactory to everyone. So I believe that this feature will have further iterations to develop solutions for these kind of spaces, which are large and open plan, where speech privacy can also be calculated and developed, taking into account what barriers are there between the desks and how much difference, how much acoustic related materials have been used inside the building. So it is a little more complex calculation. That is why I would say that this would be the next step, to take this comfort feature and enable it with the capabilities to measure for those types of buildings.
Okay, thanks, Suhaib. Actually, we have 2 more questions. Let's pick up at least one still. We still have 2 minutes. And the question is, what test procedures are proposed for establishing the actual performance rather than assumed performance? In other words, blower door testing, air quality testing, thermal imaging, etc.
I think this question is also very relevant. As we understand, conducting all these complex tests requires a lot of money. Definitely, it has a higher cost at the end of the end user and also for the EPC. So we have to keep in mind that whatever we are proposing for the EPCs has to be linked to cost very effectively. So our measurements are primarily linked to temperature, humidity, and carbon dioxide. And all the other calculations have been used or developed in order to have a realistic understanding of the comfort level inside the building. And that's why the measurements are done in winter and summer period for approximately a week. And that is done using a simple device, which is not very costly. Whereas when it comes to blower doors testing and these expensive, we have refrained from using them in the testing And these are often proposed by expensive testing measures. As you know, I've talked about different rating systems such as Home Performance Index in Ireland, or maybe talking about LEED. They all propose such measurements, but this was not a realistic decision in order to make a very cost-effective assessment system for the EPCs.
Okay, thank you, Suip. Yeah, we have another question, but I think we will use it for the panel then. I think it fits quite well there. So thank you, Suip. And let's go into the experiences from really testing what Suip and colleagues have developed. Andreas, the floor is yours. I think we said 20 minutes again, so it's 1500. So until 1520, I will remind you 5 minutes earlier.
Thank you very much, Marcus. I will try to keep the time. And thank you everyone for being here today. It's a pleasure for me to be able to present you some results out of this trial of this new tool regarding comfort feature. To be more specific, I will present you the results from the use of this tool in 4 buildings in Greece. So next slide, please. So these are the 4 buildings. We are talking about 2 residential buildings, the 2 on the left, and 2 office buildings on the right. The 2 on the left residential buildings are situated towards the center of Athens, while the 2 office buildings are situated in the suburb of Athens, something like 28 kilometers away from the city center. We are talking about 2 old buildings, the residential ones from 1976, but they have been under renovation, and they have their roof insulated, as well as their openings have been changed according to energy efficient ones, while the old office is also heavily renovated in 2000, and the office to the down right, it is a rather new office built in 2001 with many bioclimatic features. Next slide, please. Talking about sensors, the equipment we used was a sensor which could be continuously measure air temperature, relative humidity, and CO2 emissions. There you can see it at the center of the screen. And additionally, light measurements were taken from lux meter in specific days and times in every room that it was tested. Additional to that, we had also to be able to measure accurately the ambient temperature. So an extra sensor was placed in the apartments. You can see to the bottom of the screen, an onset POGO sensor, which is also data recording, while the other sensor was a PT100, very close to the offices area, gathering data in 1 minutely basis. Next slide, please. So the procedure that we followed actually was one way or another already mentioned by Seik. It was firstly to gather as much data about the buildings as we can, install the measuring equipment, try to complete to the best we can the checklists. We had also conduct surveys, and they had to be conducted during the measuring period so that we take the right feelings from the people that were using the rooms at the times of the measurement. Then download or analyze the data, and finally be able to put all this information in the tool and to be able to provide final result. Next slide, please. So we come in the part that I can give you some information regarding the results. Now, this is for the first apartment. The measurements were taken in the living room area. You can have also a sketch of the apartment with the positioning of all the sensors. The red dots refer to the lighting, the lux meter measurements. They were spot measurements, while the green triangle refers to the sensor for temperature, relative humidity, and the CO2 emissions measurements. They were taken in 2 measurement periods, both in summer and winter. You can have a look at the dates. In summer, all measurements were taken for all buildings during July, and in winter, from the end of November and until last December. And to the bottom, you can have a look at the results we finally got from the use of the tool. For the carb tool to the right, you can have a look that we managed to get a total comfort feature index of 6.1, while by the use of the curve tool, we ended up with an index of 5.1. Next slide, please. Same information regarding the second apartment. Again, in the living room, you can have a look at the living room and the places of all the sensors. The results are quite similar. For the carb, we actually got exactly the same results, 6.1, while the corp was 5.2 final results. If we could move on in the offices. Next slide, please. Okay, we see the first office room. It is a room occupied by 3 persons. However, due to the COVID situation, we normally used to find only 1 person at the room during the period of the measurements. You can have a look at the area this office is situated towards the whole building. It is a rather representative room. And again, the same kind of measurements were taking place during both summer period and winter period. And the results from the use of the tool during the asset rating to the right again, I'm giving you the high numbers first and then the low numbers. The carb tool provided us with a rather high comfort index of 6.8, while the cork tool ended up with 5.4 final results. And last slide regarding the measurements has to do with the office number 2. This is from the so-called bioclimatic building. It is a typical office room at the basement. It is actually in this building where the buildings department of press is situated as well. You can have a look at the photographs and the areas where the sensors were positioned. And we come up with the results regarding, again, the asset rating procedure. We ended up with index 5.8, while the operational rating is quite close this time with a final result of 5.5. And these are the results from the use of tool for both situations. And if we want to have a rather first idea of discrepancies between the results, next slide, please, we can have a look that the results taken. Next slide. Yeah, thank you. We have a range regarding the carb tool from 5.8 to 6.8, and from the cork tool from 5.1 to 5.5, very stable results. But the difference between the two actual procedures are ranging from 5% until 21%. The most stable difference was situated in the apartments, when the larger one in the office room. If we follow the next slide, we can have a look at some basic learnings from the application of the tool. A general idea was that the user perception regarding comfort is completely many times different than the calculated one. The second outcome is what I have already told you. The operational rating was found always lower, much lower than the asset rating index. In fact, the use and the preparation of this comfort picture in order to be able to get some final results, it is rather time consuming, and we have this to take it into account. And that's why the assessors should be well trained in order to effectively use this kind of helping hand regarding the evaluation of comfort. Next slide, please. We can come up with some pros and cons regarding this feature. In the pros, we can say that this methodology are quite clear. The information on comfort, it is useful for to the end users. They are interested in finding out what their environment, the indoor environment, should be. And regarding the degree of difficulty of integrating such an index in the national EPCs, it's not that difficult, especially in Greece, since already it has been taken into account, not in the form of presenting a special number, but taking it into account already. So it's not going to be that easy to implement it. Some barriers that we came out from the end users' ideas was that the indoor comfort aspects, they do not receive enough attention at national policy level, and they are not aware of the importance of the indoor comfort and the human health, or not as much as they should have been aware. And some extra workload and cost of the measuring equipment will have to be taken into account when will be related to the assessor's fees. So next slide, please. A very interesting workshop had taken place some time ago, and we came up with some interesting findings that I would like to share with you. There was a general opinion that the comfort and the indoor air quality are of great importance, and there is a need for an official calculation methodology widely accepted in the EU. Such, of course, an integration of these kind of indicators should require policy support and decisions on assessors' fees, and possibly setting it as a mandatory requirement would be a helpful hand in order to be able to push further the use of such an index. And finally, some comments and doubts were expressed in relation to how representative the spot measurements were and how well accurate these, and especially for the core indicator, could be during the measurements, because we only 2 weeks are a very, very small time in order to be able to calculate the use of the room and its perception for the whole year. So this is a rather important aspect that we should take into account, especially when we are going to use measuring equipment for this kind of index. And my final outcome, let's say, or we can also call it conclusions, is the next slide, where we could say from our personal way of using this tool is that the methodology that has been applied through the X-tendo project and the tool, of course, are well defined and quite easy for us to use. This comfort index can be implemented as an official calculation methodology, why not, at EU level, and of course at national level in more specifically. The user perception is more favorable than standard conditions that came up from our survey, and people were thinking that they're feeling better, but from the measurements point of view and our results, we got lower values from the comfort index. Great attention must be paid where completing the survey in order to correctly record the use of acoustic and light measurements. That means that many times, especially during the completion of the survey, many answers were related to the people and the person that was answering the survey. Some wanted to have many light, high light intensity, and the person next to him wanted low light intensity. And that was a little bit of a problem for us, what we should put as an input to the tool. One way or another, more validation of the tool should be carried out in order to be much more accurate about these comfort index results. And finally, already said actually that the assessor's effort somehow should be quantified. And that's the end of my presentation. Thank you very much.
Thank you very much, Andreas. Perfectly in time. That's also why I didn't remind you. Thanks for the interesting insights from the Greek case. I really think this is very important for the development of such new ideas to really see how it works in real life. We have a question related to, as you have also stated, so there has been efforts involved in really coming up with the indicators in how much would that cost, and how much would the increase of the costs be for the EPCs. Maybe you can say some words on your Greek case to that. How relevant is that for the Greek case?
Yeah, we actually tried to somehow quantify the time needed for making this index working and be able to provide the result. And there are two possibilities, because the corp, it needs much more attention and much more work, because when measurements are included, Are you going to put the cost of the measuring equipment inside or not? One way or another, the time we calculated we need in order to provide with the result ended up with more or less extra cost of about 100 euro. But without putting the equipment cost or anything that has to do with this kind of with a measurement point, mainly for the CARP procedure, 100 euro. For the corp, it's going to be slightly more.
Okay, thank you. Yeah, actually, of course, the question remains of the measurement equipment, but clearly this could then be used not only for one building, so it has to be it could be used in several buildings. But anyhow, the assessors will need or might need then to buy the assessment equipment and have it. All the assessors need to have it. Yeah, thank you very much. Actually, we have 25 minutes for the panel discussion. Yeah, let's go. I will try to pick up questions that we have in the chat and also try to come with more generalized questions into it. And I would like to start about thinking about we have or the colleagues from BPIE, they have come up with several dimensions of comfort. So we have the thermal comfort dimension, we have the indoor air quality comfort dimension, we have the acoustic comfort and the visual comfort. My first question to all of you would be, what do you think which are the most relevant for the end users? So which of those do you think should have more attention than others or equally between those? And at the same time, I would say, let's put another question in parallel. Do you think this including or knowing about these features, so about these properties of the buildings, will have any effect on real estate transactions? So are users really going to put their decisions based on such indicators? And maybe let's start with you, Andreas or Elpida. Let's hear from yours, from the very applied case. What do you think?
Okay. Hi. Thank you for the question. I hope you hear me.
Yes.
Okay, great. Well, regarding the first question, it's actually not let's say a straight answer, because as Haib said earlier, it depends, of course, on the type of the building, on the users, because as Andreas also mentioned, in one office we had two users with two completely different opinions regarding, of course, the same comfort feature, light visual comfort, as Andreas said, but it's the same with thermal comfort. One person may need to be let's say more fresh, the air, especially if he's a male, because you know sometimes females are more, they need more heat in a way. So I wouldn't say that there's only one answer. Of course, the last 2 years living with this COVID situation, special focus is given to indoor air quality, because of the health hazards that we need to face and to limit these values. So I would say that more or less it depends on the user and where he is, because sometimes in his house he wants, let's say, another kind of comfort feature that wants to to focus on. And if he's at the office or at the school or elsewhere, he has another, let's say, interest. Now, regarding the second part of your question, which is about real estate transactions, what I would say here is that, of course, comfort will affect the real estate transactions, and this is because comfort, let's say, pushes the buildings to a better performance. So there will be need for not only energy efficient buildings, but also optimal buildings with optimal comfort conditions. So of course there will be a change in real estate transactions, and this also affect the value of the building.
Thank you.
Thank you.
Thank you. Suhaib, do you have to add here?
Thanks for the good question, Marcus. I think indeed, I second the points that were mentioned by Alpida here regarding that the interest in different indicators varies according to the user and also different building types. And we have seen this in our initial stakeholder investigation, where we found that different users have different priorities. However, one striking thing that I can answer here that we noticed was the most interest was observed in indoor air quality and thermal comfort, followed by acoustic comfort and visual comfort. So we see a direct relationship of building performance in terms of thermal comfort that directly impact the end user and is very much noticeable in their day-to-day life. However, we cannot forget that in countries like Poland, acoustic comfort could be more problematic where the envelopes are not that great. However, in countries such as Denmark, or I can say maybe in Germany, the buildings are very well insulated for the sound as well. So that's not a major problem. So it really depends also in the member states, the kind of building technology that have been there over the past years, what is the building stock condition, the users, and also the building types. So it's very much variable. And I also see the real estate transaction being affected by it very much, because there's a deep interest of end users when they go for renting, buying, or selling their buildings, that our building should be good, should be comfortable. Whenever somebody is going to rent a building, we definitely try to look at, is it going to be comfortable? Is the heating working well? The questions are very much related to comfort. Is there is lighting in this room? Do you get sun? So I see there is an understanding in the end user, but there's nothing in the EPC or in their hand to actually assess that when it is said orally by someone. So energy performance certificate depicts the energy performance, but it does not depict these indicators. And I feel that it will empower the end user to make the right decision in either improving the building, renting the building, buying or selling. So I see a positive influence there.
Okay, thanks, Suhaib. I think it's also a very good add-on that this is, of course, depending on the different users and the different buildings, but also very different in different member states. I also think it has been quite discussed or more in the focus in the last years due to the COVID situation. So quite more focus on it. Now, maybe a question to Pao. I hope you're here. Yes. Cool. You have mentioned that in the current discussion in the recast of the EPBD, you're also thinking about suggesting to integrate somehow an indication for comfort. And was there also quite a relation to this? Was this also coming more due to the COVID discussions and promotion of healthy buildings, or is this not related? How important is it in the discussions in the EPBD to promote healthy buildings, not only focusing on energy efficiency, but also on other benefits, primarily such as healthy buildings?
Thanks, Marcus. I would say that this has been an ongoing concern for us for many years. There's been a discussion, or there have been comments sometimes that energy performance can come at the detriment of comfort or indoor conditions. And for us, this is absolutely not the case. Energy performance comes secondary to indoor comfort and, thermal comfort and indoor air quality. So there is that. However, yes, the current pandemic has given much more visibility to all issues related to particular indoor air quality and ventilation. And there we had detected through several studies that indoor air quality conditions were not always the best, and that a lot of ventilation systems were underperforming. In some cases, even though they were still maintaining their bare minimum air quality levels, they were definitely not performing as well as they should have been. So these are something that has given much more visibility. With regards to how we looked at it in the revision of the EPBD, we had discussed one of the options was to introduce specific requirements at the level of indoor air quality or thermal comfort. However, this is the prerogative of member states. So it's a little bit out of the scope of the EPBD. What we've done is emphasize the fact that they need to comply with these minimum requirements, and then we want to give more visibility to those elements that can ensure that indoor air quality and thermal comfort are maintained. So that's why the EPC, one of the possible indicators is visibility of systems that monitor and control these kind of conditions, rather than you need to achieve these conditions.
Okay. I guess you also expect that an influence of such an indicator might be seen in the real estate transactions, and also maybe a push for renovation financing. Is there any monitoring foreseen from your side, from the Commission, where you think you're going to analyze in the next years how this might be affected, or how to let's say try to push it in a certain direction, or is it still not planned?
We do plan to look at the issue of indoor air quality and thermal comfort, then yes, and how it's going to evolve. The specific relationship between indoor air quality and real estate prices, I have to say it's not something that we have looked yet. It could be interesting, and I would expect that particularly in the retail sector, so offices and anywhere where we have to share the space with other people, these kind of high performance systems will have more value. Exactly how it's going to translate, I don't know. If we will be able to attach a price tag, I don't know for sure. This is to be seen, but I would expect an influence for sure.
Yeah, no, and maybe it's still not under discussion, but I mean, one option that there is definitely there is to make it necessary to include it also in platforms where buildings are where the transaction take place, no? Mm-hmm. Just for example, yeah. Yes, so I've also seen that we had some questions on the weighting between the different parts or the indicators that in total make up the comfort. Maybe a question to Suhaib. On the one hand, so how did you come up with the weighting of the different parts of the comfort indicator against each other? And on the other hand, a related question, maybe you can shortly say about how sensitive the indicator is also to user perception, so the perception of the comfort of users that are included in the survey in the overall results.
Thanks, Marcus, for the question. It's very interesting, and one of the foremost things that we actually looked at in the sense how we do go about giving a specific weightage either of the indicator. As I expressed that it is very much variable based on the needs of the end user, based on the type of buildings, and also the geographic location. There can be several factors which can determine this, and they are varying from one member state to another, and also by region. So I think the answer to this would be not so simple. It would be, it really needs a deeper investigation into the national priorities, and also understanding the condition of the existing building stock, whether it's new or old. Then on the basis of that, it could be defined for a certain age of the buildings. For example, you can decide a higher weightage for acoustic comfort and indoor air quality and thermal comfort, and might not give much weightage to visual comfort. So it is just an example, and I'm trying to tell that we cannot decide and fix it. That is why we try to keep all of them at the same level during the development of the tool. However, during testing, we will learn more about this, specifically for the countries such as Greece, Portugal, or Romania, who are testing this. So we will have a specific insight for those countries based on the test pilots. However, this needs further elaboration and also study into the national perspective and making sure, for example, if the outdoor air pollution is very high in a certain country or maybe in a region, we need to see how important is indoor air quality in this certificate and should we give it a higher rating. So it is difficult, but it needs further elaboration on this area to finalize these ratings. Finalize these weightage for each indicator. And perhaps that's the solution. However, our tool is fully flexible and member states can adapt to whatever weightings they would like to use for each of the 4 indicators. Regarding your question, how we take into account the end user perception and to what level does it influence the rating? This is a very good question because we had the fear in the beginning that if the perception of the end user is biased, they can always say, I feel good in my house, lighting is good and everything is good. But that would actually bring a bias into the outcome of the rating, and that can be exploited as a rating which is positive during selling or buying and things like those. So transaction will be affected by it. So what we did as a measure to counter this issue was to reduce the weightage that we are given to user perception in the whole calculation process. And this is a process that is undergoing. We will calibrate this weightage, whether it's 20%, 25%, or 15%. We will decide based on the outcomes of the testing that is already going on in different countries.
Thank you, Zoev. Let's go a bit into really imagining that we implement such a feature into the EPC framework of a country. I would direct the next question firstly to you, to Greece, Elpida or Andreas. I had a look at the different testing results from the different countries. So one outcome was definitely that the main challenge in implementing it, or one of the main challenges, is related to the measurement, as you also have already pointed out. So in that sense, there has come up the idea of maybe could it be interesting to only include the CARB part and not the core part. So actually, in order to have less effort for the assessors, more easiness to include it. First question, what do you think about it? Second question, which steps actually would be needed, next steps, in order to start the implementation of such a calculation into EPCs in Greece?
Okay, may I address? Okay, thank you. Thank you for the question. Well, I will start from the second part, actually. Regarding, let's say, the framework that it is needed in order to have to start this implementation, I would say that it would be an easy, let's say, way to if we could have this methodology as a mandatory requirement in relevant national incentive programs. So if it is funded in a way, this methodology, the implementation of this methodology would be a good starting point so that the people, the users and the assessors would have a supporting way to start implementing it. Now, regarding the first one, what we faced is that in Greece, as most of you know, the winter starts quite late. So, regarding the X-tendo project, when we were scheduling the measuring period, November was the first our first plan, but at last we didn't have this chance because November was quite warm compared to other countries. So measurements would be a good indicator for the assessments. However, it is not fixed how we can the periods and the time that we will need, because it is not very representative the periods among all the countries, of course, and in one way or another, probably measurements would be let's say not mandatory, but to be something supported in the CARP tool. So Andres, if you have something to add.
Yes, yeah, I agree. I quite agree. In fact, the measurements, as I also mentioned it in my presentation, we were having some doubts whether how accurate these measurements were, because one way or another they took place during the COVID period. So in terms of the office room use, we weren't sure that these were the nominal, let's say, conditions when all people, all three persons, for example, in one office and another, and all the other persons were present. So we had many doubts regarding the conditions and the measurements and the accuracy of the measurements and how representative these measurements were during the calculations. We, of course, input the data, but we have strong doubts whether these are the right ones. We had to take into account the typical use of this room, building, whatsoever, and be able to accurately know when it's going to be in full use and then take the measurements. In both, of course, always at least time periods during the year, summer and winter. One and another example, as Elpida said, is that the winter in Greece comes a little bit late. So in fact, it came to Greece, but it came too late, and we should have already done these measurements. It came mid-January. We had quite cold days, but it was too late because we had already, from the work package timetable, should have finished the measurements. So the right time to do the measurements is a very important issue, and in order to be representative. Also, the use of the room must be in the as it should be. I don't know if you understand what I'm talking about, and not in some kind of 70% true or complete.
Yeah, it's always a problem with measured data. No, how representative are they really for a certain average condition? Yeah. Thank you very much. Maybe Suhaib, what did you learn out of the feedback that you have received from testing these indicators in the different countries, and maybe also in relation to other indicators of comfort that exist, like, for example, as we have had it in one of the comments, that there is this tail indicator for indoor environmental quality. So maybe you could, which is, as far as I understand it, as far as I know it, a very complex indicator. So it needs much time to assess a building to come up with this indicator for a building. So the intention was to have an indicator that is possible to be assessed with less effort? What is your learning now? Is this effort that you suggested still too much in order to be included into an EPC or not? Yeah.
Thanks for the question. First, I would like to really address the effort part, because like you said, TAIL, it has been a reference for us in the beginning. We looked at it and we realized it requires a lot of measurements and monitoring for over months to be able to come up with an indicator which is not for all types of buildings. It is, I think, primarily for office and hospital, hotel buildings. So if I remember correctly. So they did not develop a tool that could really address all types of buildings. So there was one gap that we identified. And for us, it was difficult to think that their methodology could help us in developing something more simpler, because they already are very much dependent on the measurements. Our intention from the beginning and the policy was always it should be cost effective, time effective, and easy to be performed by the assessor, as we understand that there are training requirements for this kind of feature, which differ from energy performance evaluation. There are many inputs that would be entered into the calculation, which the assessor would not know unless they have a training that how to do these kinds of assessment and what to understand out of them. So this is a basic thing, and we have tried to develop a simple process with a very detailed guideline explaining which part of the tool requires what and what has to be assessed on the field, what you are supposed to capture in order to do the complete assessment. Now, since during the development, we already took into account these limiting factor or constraints, we also wanted to see how they perform in the testing. So our partners from Greece, Romania, and other countries, they started testing, and we noticed that there have been some issues in calculations, or there are some scales that are not very well balanced according to their national requirements. So we started taking note and learn from their national priorities on understanding that what should be the level of, say, illumination inside the buildings based on their overall, sun exposure throughout the year, in particularly in different regions of that country. So what we tried to indicate, we divided the climatic conditions into regions of those countries, take into account heating degree days and cooling degree days as well in our quantitative calculations, and also complement it with the qualitative assessment. So we have learned that there are different geographical needs and priorities emerging from these countries, and we need to calibrate the tool to their countries and their local conditions. And this is what we are going to do once we receive the results for these testing countries. But there can be further calibration possible for any other member state who is interested in testing it, and it won't be a very difficult job to mold this tool and make it useful for the other countries if they're interested in using it for their EPCs. I hope I answered your question.
Perfect. Yeah. Thank you, Suhaib. Yeah, with those words, I would like to go into the final sentences. Thank you very much, Suhaib. Thank you very much, Elpida. Thank you very much, Andreas. Thank you very much, Pau, for your very valuable inputs. Thank you also for answering directly in the chat to those questions we were not able to pick up in the panel discussion. Yeah, I think it was a very interesting run into this comfort idea. So how to measure comfort and make it more visible for the buildings, and not having first energy and then comfort might be another benefit that comes, but turning it around and say we want to have comfortable buildings primarily, and of course they should also be energy efficient. There will be of course this webinar available, but also all the materials that we have developed during the project. You can find it on the X-tendo website, so it's www.x-tendo.eu. And we're going to have a toolbox there. We call it toolbox. And for all of those 10 features that we were working on, there will be one box, let's say, where all the information that we have developed can be found. And it's split up into, let's say, background information, then on tools that have been developed. In this case, it will be different spreadsheet tools that you can download and use and have a look at. Also guidelines, as Suhaib has mentioned, so guidelines how to use these spreadsheet tools, then which inputs are exactly needed and how is what calculated. And also, which we are currently working on, is how could an implementation go on in the different countries, and how could it be different? What are things that should be taken into account? What should the things that should be started with? That's going to be elaborated in the next months. So check out the website or directly come up with questions to any of the board, the panel. Thank you very much. And with that, let's close the session. Goodbye. Have a good afternoon to all of you. Thanks again. Bye-bye.
Yeah, goodbye.
Thank you very much,
Good afternoon, everyone. Thank you
Bye.
very much.
Bye.
Good afternoon.